Okay. Can you give me one of the problems from the homework last night that you said you struggled with?
Let's do
Yes?
72. Let's do 72. Why not?
72.
Why not?
Secant,
That's the last one we had, right? 72 is the last one. 74. Okay, well, yeah.
secant squared x,
Plus 2 secant x
secant x
minus 8.
minus 8 equals 0. All right, so, okay, so secant x times secant x, 4 and 2, positive and negative. So the secant of x equals 2 is one equation, and the secant of x equals negative 4 is the next equation. So cosine of x equals 1/2, and cosine of x equals negative 1/4. Now this we know the solutions to. We're looking at from 0 to 2 pi. What are the solutions to cosine x equals 1/2? Pi over 3 and 5 pi over 3. They are not separated, unfortunately, but that's okay because we just wanted the interval. So there are some solutions there. Now for cosine of x, 1/4 is not one of the answers that we know. So we're going to do the cosine inverse of negative 1/4, which, we'll have to type that out on a calculator. So that's going to be in quadrant 2 to be a negative number. So that's going to be, when I start drawing this, negative 1/4, it's going to be maybe about here, and then its complementary version down here. Now, unfortunately, these are not separated by pi. Okay? So the only thing I can do to get the second solution is I'm going to take this answer, what it is currently, cosine inverse of negative 1/4. That's a quadrant 2 angle, and I want to go to quadrant 3. So what I'm going to do is I'm going to end up taking, let me make sure I get this right, cosine inverse of negative 1/4. Take it out of 2 pi. Would that work? Yes, that would work. So 2 pi, try this again, 2 pi minus that answer. Yes, 2 pi minus that answer would give me the solution down here. There we go. So you have to know how to factor. Well, again, the reciprocal, the secant of x by definition is 1 over the cosine. And so if the secant of x is equal to 2, that means the cosine of x has to equal the reciprocal of 2. So this part, the reciprocal part, is by definition. All right, I can do one more. Let's go ahead and do one more. Yeah. 67? 2 cosine squared x minus 5 cosine x plus 2 equals 0. And so this factors into cosine x, 2 cosine x here. And then the 2 would factor into 2 into 1, and then minus and minus. And so that would give me a middle term of negative 5. Perfect. So that means cosine of x equals 2, which is an impossibility. Cosine of x can't be bigger than 1. So that equation is thrown away. And cosine of x equals 1/2. And so when we first were introduced to the cosine, remember cosine of x and sine of x are bounded functions. They're part of the bounded family. And so their absolute values are always less than or equal to 1. That's why we threw this one away. Can't equal 2. And then the solutions to 1/2 is pi over 3 and 5 pi over 3. And so those are the only two solutions in the interval from 0 to 2 pi. Yeah, tangent can't equal pi over 2, or the theta can't be pi over 2 because that would be a vertical asymptote. Yep. Yep. Okay. All right, now, just so that no one's shocked or surprised, now it is an early release day, so you're not going to have very many questions. I can't give you a 40-minute quiz.
That's true. How many questions are you going
3 or 4.
Oh! That makes it worse.
So, what you need to do to be prepared for tomorrow is, out of the homework that I've given you, you need to study the odds.
Don't tell us.
No, you would fail. This is 33 points. Per question.
You guys should know me better than that by now. I'm surprised that you don't. I don't grade it like that. Now, if you get one wrong, yeah, it's not going to be an A, right? But it depends on how much work you show me and whether your thinking is correct. I mean, if you make small arithmetic mistakes, and if that's what's getting the problem wrong, then that's going to be far less of a penalty than if you just don't understand what a cosine is, right? You need to know. Well, I don't know if I have an answer to that.
Show my work and I get the right thing, but the wrong answer.
Okay, guys, take out your math journals, please. 5.4. These are called the sum and difference formulas. If you have two angle measures, u and v, and you have the sine of u plus v, it turns out that this is equivalent to the sine of u times the cosine of v plus the sine of v times the cosine of u.
Whoa. That is, quite the proposition. What? Quite the theorem. What?
So let's say I had sine of 7 pi over 12. Now it turns out that 7 pi over 12 is the same thing as pi over 3 plus pi over 4. Cross multiplication. Middle school. 4 times pi, 3 times pi, 4 plus 3 is 7. Multiply the bottoms. 7 pi over 12. And so using the formula, this is the sine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 4 times the cosine of pi over 3.
What?
Well, we've all memorized this. Sine of pi over 3 is now equal to the square root of 3 over 2 times the square root of 2 over 2 plus the square root of 2 over 2 times 1/2. And so this is the square root of 6 over 4 plus the square root of 2 over 4, which I can write as the square root of 6 plus the square root of 2 all over 4. That's how it works. Talk to me. Why is that confusing?
I think it's fine. It's more blunt.
Where did cosine even come from?
Well, it's from the definition of from the formula.
Well, why can you just assume that cosine is allowed to be there? What? Because that's sine u plus v is equal to sine u cosine v plus sine v cosine u.
This is an identity.
Yes, but I want to know why the identity is allowed to happen. Allowed to happen.
Why is the identity? Okay, so in other words,
Pull up the cosines there, because there's only sine at the beginning, and then you have two cosines popping out of nowhere.
okay, they're okay. So actually, what you're asking for, it's not unreasonable what you're asking for at all. You're asking for the proof.
Yeah, that is what I'm asking.
That's what you're asking for.
That's what I'm asking for.
You're asking for the proof. Now, while that is an excellent question, the next question is, can I provide the proof without having prepared necessarily for the proof? I mean, it's a great question, and I have proved it in the past. I just want to make sure I can actually prove that. So, let's see here. Okay. This is going to be interesting. Da, da. U plus V.
Wait, not fascinating now. No, I asked the question and you said that I was stupid for asking the question. I didn't say that. Yeah,
Yes, you did.
Yes, you did. I was like,
Is this even a road I can take? H X Y A B. Okay, so let's see. Can this even happen? So can I put that on top of that? You know what? I'm not going to ignore your question. I'm going to come back with a proof a little bit later for you. Okay? Gabe, this is true. This is true. Okay?
I'm being asked to believe something that I have no proof for. Just believe.
Is it okay?
I won't.
Why is he one? An angel? Oh. I thought it was like a nose and a mustache.
Okay?
Angel Gabriel.
I will not ignore your question. I will look up the proof and we can go through the proof, okay?
Okay.
All right. Here's another identity. The sine of u minus v is the sine of u times the cosine of v minus the sine of v times the cosine of u. Yeah, they have more or less the same proof. All you would do is you would change v into negative v and run through the same proof again. Okay, so the sine of pi over 12 is the same thing as the sine of pi over 3 minus pi over 4. So that's the sine of pi over 3 times the cosine of pi over 4 minus the sine of pi over 4 times the cosine of pi over 3. And that's equal to the square root of 3 over 2 times the square root of 2 over 2 minus the square root of 2 over 2 times 1/2, which turns out to be the square root of 6 minus the square root of 2 all over 4.
I have a question. How'd you do that so fast, like that math of multiplying the square root?
I have been doing this a long time. Square root of 3 times the square root of 2, 3 times 2 is 6. There you go. 1 times the square root of 2 is just the square root of 2, and 2 times 2 is 4, so they have the same denominator. That's why I can bring them together.
Oh! Yeah.
All right? let's take the following problems. If the sine of u is 4/5, where u is in the first quadrant, and the cosine of v is -12/13, where v is in the second quadrant, then can I find the sine of u plus v? So this is quadrant 1, and this is quadrant 2.
So,
And that's okay.
so basically, are you taking, like when it says sine u, you put 4/5 in?
Well, what I do first is this. I draw my quadrant 1 triangle, okay? So this is angle u right here. And the sine is the opposite over the hypotenuse. So that's 4/5. So how much is the adjacent side here? Yeah, the adjacent side is 3. And then I draw the second picture in the second quadrant. And there's my triangle. And so this is angle V. And cosine is the adjacent over the hypotenuse. So that would make this side how much? 5, Pythagorean theorem. Okay? I've been doing this for a while. Okay?
Yeah, that makes sense.
Now this is the sine of u times the cosine of v plus the sine of v times the cosine of u. Do you see why I drew the two triangles first? Yeah, I'm going to have to figure out what the cosine of u is. And I couldn't have done that unless I had drawn that triangle.
So cosine's 3/5.
I'm also have to figure out what the sine of v is, and I couldn't have done that without the triangle. Now the sine of u I already know. That's 4/5. But the cosine of v, well, okay, I know that too. That's -12/13. Now, it's the second part that I wouldn't have known, right? Sine of v is now what? 5/13. And the cosine of u is 3/5. Well, the denominator is going to be the same, right? 65. So this is -48 plus 15 all over 65, which is -33 over, whoops, that's a 64. I don't know why. Over 65. I think I did my arithmetic correct. Oops. And so we draw the quadrant triangles first. Because from the quadrant triangles we can then determine what the value is. Okay?
So the answer to it is just -33 over 65.
Correct. That's it. That's the answer. What do you draw first? The quadrant triangles. Alright? Okay, now sometimes you're going to be given something like this.
There's always a but.
I didn't say but. I said now, sometimes. That's all I said.
Well, yeah, but he does that too. But sometimes. But maybe change the wording. But maybe. Different word. Uh-oh. What? No. That's not allowed.
Just take a deep breath. Just focus on what he's saying.
L1? Is that 97? What's that? 97.
That's a 1.
L1
97.
or tail.
Dark tail. She already made that joke. Just small.
Okay, Seth, when you're given a problem like this, you may assume that we're dealing with quadrant 1 for the sake of drawing the triangles. So
Triangle.
here we draw triangles from a quadrant 1 perspective. Okay. Now 1, okay, we're focused here, please. 1 is the same as 1 over 1, is that correct? Okay. So the first one, tangent is opposite over adjacent. So 1, 1, and so this is the square root of 2. The hypotenuse is the square root of 2. Now the second triangle, I'm going to have to put that as x over 1. And cosine is what over what? Adjacent over hypotenuse. So that makes the opposite the square root of 1 minus x squared. Okay? Now, cosine formula. The cosine of u plus v is equal to the cosine of u, cosine of v, minus the sine of u times the sine of v. Yeah.
Why would you say the square root of 1 minus x squared? Why can't you just say 1 minus x? Because then you can just take the square.
No, you cannot take the square root of a difference. The square root of a difference is not equal to the square root of the parts. This is not true. Well, actually, the way that I wrote, I said not equal to, right? So this is true. The left is not equal to the right, right? So you can't, the square root of a difference is not equal to the difference of the roots. So the square root of a minus b is not equal to the square root of a minus the square root of b. It doesn't work that way. So that is the simplified form. That is the simplified form. Now cosine of u, so this is u and this is v. So cosine of u is what? Nope. This is the sum formula for cosine, and the cosine has a minus in the middle here. Yep. All right, what is the cosine of u? Yes, I'm going to put 1 over the square root of 2, but you're absolutely right. It does rationalize to that. Cosine of v?
Oh my.
X over 1. So x. Minus sine of u. And then sine of v.
1 minus x squared.
Square root of 1 minus x squared. And so the final answer is x minus the square root of 1 minus x squared all over the square root of 2. But now I am going to rationalize that. And so that's x square roots of 2 minus the square root of 2 minus 2x squared all over 2.
Yes, I see. Since you have the square root of 2, it goes.
You multiply the square root of 2 on the inside. That gives you what you need. So there's the final answer.
What? Wait, what? I would really just do all the odds in the back. Cut it in half.
He says in front of the math teacher.
If you give me 100 problems, that's how it's going to go down.
That's how it's gonna go.
That's how it's going to go down. 100 problems is way too many. I mean, college probably get
Yeah, but it's all.
So the tangent of u plus v
why is fun.
is tan u plus tan v all over 1 minus tan u tan v.
What? Oh, well.
Tan u tan u. Yes, exactly. So the tangent of 7 pi over 12 is the same as the tangent of pi over 3 plus pi over 4. And that's the tangent of pi over 3 plus the tangent of pi over 4 all over 1 minus the tangent of pi over 3 times the tangent of pi over 4. Now the tangent of pi over 3 is the square root of 3 minus 1 over 1 minus the square root of 3 times 1. That's a minus. Oh, that's a plus. That's a plus. Sorry, my bad. Forgot my plus. Now I have to multiply the top and the bottom by the conjugate. Foil out the numerator. 1 plus 2 square roots of 3 plus 3. Foil out the denominator. 1 minus 3. And so this becomes 4 plus 2 square roots of 3 over negative 2, which is negative 2 minus the square root of 3.
Yeah, guys, yeah.
I get. Okay. Yeah.
10V. Okay.
We apologize for this.
We are experiencing technical difficulties as Mr. Partridge has an emotional breakdown. If you hear screaming,
Please enjoy this music.
please move on to another YouTube video. And thank you for your patronage. Okay, can I erase it? All right.
The tip of my pen just fell out. Maybe if you stop chewing on your pen all the time.
Okay.
You can do that.
The tangent of u minus v is the tangent of u minus the tangent of v all over 1 plus the tangent of u times the tangent of v.
So it's just basically switching the sign.
Switching the signs. The weird one is the cosine one.
Yeah, that one.
The cosine of u minus v is equal to the cosine u cosine v plus the sine of u sine of v. So whatever the sign is here in the cosine, you take the immediate opposite of it in the middle of the two expressions. But sine and tangent, well, sine works exactly as it's supposed to, right? Sine of u minus v is sine u cosine v minus sine v cosine u. So that works exactly the way that we think it should. Tangent is a little bit of a swip swap. So whatever, I like that word, swip swap. That's my new favorite word. Minus sign. So the minus sign will appear in the numerator and the plus sign will appear in the denominator for tangent. But the numerator and the denominator should have opposite signs. But if I switch this to a plus, then the plus appears in the numerator and the minus appears in the denominator. That's the way that works. Okay? Turn to page 402.
This I will do. How in the world does that happen?
Look at numbers 13 through 28. Find the exact value of sine, cosine, and tangent. We're going to do number 27 together. And I'm going to let you choose which function we're going to do. Oh, dyslexic am I now? Not that that's a problem, because it isn't. Do you want me to do the sine, the cosine, or the tangent?
Sine. Let's do sine first. Or cosine. No, cosine's supposed to do.
Tangent is the most
Okay, we'll do the tangent.
Let's have a
Okay. First thing I'm going to do to make my life easy is I'm going to take 165, negative 165, and I'm going to find a coterminal angle. So I'm going to add 360 degrees to this to go coterminal. What is 360 plus negative 165? Take your calculator real quick. My brain is just not doing it. It's not pulling it. It's 195, I think, is the correct answer. Just double check me. Am I right? Okay, good. Now, 195, 20 and 75, 180 plus 15 degrees, 135 plus, yes, okay. 195 is the same thing as 195, excuse me, is the same thing as 135 degrees plus 60 degrees. These are two angles that we know from the unit circle, which is why I took the time to make the coterminal angle. So what I'm really doing, what I'm really being asked to do now is to find the tangent of 135 degrees plus 60 degrees. That's what I'm being asked to evaluate. That'll be the same thing as the tangent of negative 165 degrees, because again we have a coterminal angle. So far so good? Again, we had to separate this, and that's what you're going to have to do in this lesson. You're going to have to separate sometimes, like for example 21 through 28, they don't give you the separation of the two angles. In 13 through 20 they do. They tell you what they separate into. So you're going to have to find two angles that from our unit circle that either add or subtract to be the number you want. So okay, to be the sum of the inside. So we've got 135 plus 60 degrees, and now we're going to use our formula. So this is the tangent of 135 degrees plus the tangent of 60 degrees all over 1 minus tan 135 times tan 60. All right. 135 is quadrant 3. No, quadrant 2. Is tangent positive or negative in quadrant 2? It's negative. So that's negative 1.
What?
Yeah. Over 1 minus negative 1 times the square root of 3. Minus minus is a plus. And now it's time for the conjugate. This was a minus negative 1, and so 1 times the square root of 3 is the square root of 3. So 1 plus the square root of 3. 1 minus the square root of 3, 1 minus the square root of 3 is the conjugate. And so the numerator becomes negative 1, the plus 2 square roots of 3, minus 3, all over negative 2. That's negative 4 plus 2 square roots of 3, all over negative 2, which is 2 minus the square root of 3. And there's the answer. That's the tangent.
I understood about half of that. Okay, so you're taking. Okay. Oh, okay, I get it. So you're basically doing FOIL for the top and the bottom when you multiply by the complex conjugate?
It's not a complex conjugate.
No, it's not. It's just a conjugate.
Right. What would it take to be a complex conjugate? Yeah, it would have to have an I in it. That's right.
Oh, I say that every time. It just looks complex, that's the thing.
Right. So again, if you have, whoops, for the sake of studying the conjugate, just kind of for the sake of that, if you have the square root of A plus the square root of B over the square root of C minus the square root of D, the conjugate of the denominator is the one that you want. Now the denominator, if you understand the FOILing process, is going to be very quick. The denominator is going to be c minus d. The numerator is the FOILing process. So that's the square root of AC plus the square root of AD plus the square root of BC plus the square root of BD. And that's as far as I can take it because there are no like terms. So that, for the sake of studying the conjugate, that is kind of what you have to do. Except it's actually easier now with the tangent because we had 1 minus the square root of 3. So we actually have something we can combine. That's where the 2 came from. That's exactly right. That's exactly right. Yeah, 1 minus the square root of 3, 1 plus the square root of 3. So we had to multiply by 1 minus the square root of 3, 1 minus the square root of 3. Now the denominator becomes 1 minus 3, which is negative 2. The numerator becomes 1 minus 2 square roots of 3 plus 3. So there's my 4 minus 2 square roots of 3 over negative 2. Now it's negative 2 plus the square root of 3. That's how it works. That's how conjugates work. So you're going to do numbers 13 through 28. That's the homework assignment. 13 through 28. Why am I being so nice? Because you have a quiz tomorrow. Now, for those who are listening, which is a good thing to do, you should study the odds. I'm thinking of lesson 5.3 now. You should study the odds 11 through 23, and then the odds 63 through 73. Okay? And I will ask at least one multiple angle. Okay? So odds 39 through 43. All odds, because the odds are in the book. Alright? So I'm going to shoot for 4 questions, but again, we only have 30 minutes.
15 minutes per question?
No.
That's not
No. Out!
Alright.
All right.
Phillips in pre-calc. Yeah, Zillow though.
And that is pre-calculus. God bless you, wherever you are today.